web browsers provide limited access to the local file system, and that's for obvious security reasons. So for our app to be able to create, write, and read files from a local file system, we need access to the native Ionic file plugin. Both iOS and Android operating systems are based on various versions of Unix. So iOS is based on FreeBSD and Android on Linux. Normally, when a computer runs Unix, a user will have access to the command line, and if they have root access, will be able to access the entire file system. Due to security concerns, the file systems on phones is strongly locked down, historically more so for iOS than Android. The app is run in what is called a sandboxed environment, where the app has limited access to certain parts of the operating system, and the user may be explicitly asked to allow the app to access certain parts of the operating system. Android and iOS provide different storage location options. The File plugin provides 2 storage locations which work on both Android and iOS. So we'll have our data directory where we can put app-specific data files, and a cache directory, and the cached file which will hold the cache files that should survive app restarts, but the app should not rely on the operating system to delete any files that are in there. Your app has 2 types of storage locations. The first of these is the directory of the app that was compiled on the desktop computer. This is read-only. This is fine for our CSS, our HTML, our JavaScript, and other resources known at the time the app was compiled. The other is a data directory, which is unrelated to the apps directory. This directory is writable and can be used to store uploaded photos, databases, and other user-created files used by the application. So why would an app need a read-only data storage? It's an example of your electric car charging app may have the locations of all of the charging stations stored in a data file, which is never written to, only read. So read-only storage is used for data that is shipped with the app and never needs to be changed. Read-only storage will actually be a part of the app itself, and you specify the files in the read-only storage when you build the application. Note that a read-only file can only be updated through an application update. Writable locations are not part of the app build process. You cannot define what is in the writable locations when building the app. Instead, while the app is running, you can create new files in a writable location and later read from them. As a result, you can't have any default data which will automatically appear in the writable location when the app is first installed. Example like our charging locations in the previous example. If you want to have a default data set that can later be changed, you can provide the default data set in the read-only area and then copy it into the writable area when the app first runs. You could do a check to make sure if the file exists in the writable location each time the app launches, and copy from the read-only location only if it doesn't exist. You don't want to be writing over someone's existing data. So writable data will disappear when the app is deleted. This is a consideration when designing the application. Android also has access to the broader file system where a user can select to store data in any location. E.g., on Android we do have access to an SD card. So iOS has historically been much more limited and only recently has provided access to a files and folders system and also iCloud. To install the file plugin, you need to follow the same process we have used with other native plugins. So firstly, we install the Cordova version plugin. Secondly, we install the Ionic native version of the plugin via npm. The plugin must then be declared in the module that will use it and be added to the providers array of the ng module decorator in that module. We can then import the Ionic native plugin into a component and then inject it via a constructor. The application directory can be used to determine where the application directory is located. This is just one of the many methods available on this file plugin. Using the this.file.application directory method allows us to get a path that defines the directory of the application. In the iOS emulator, the app is located at ~library/developer/core simulator/devices, and from there on. In Android, it is something like file://android_assets. So you can locate these directories in your file system. iOS applications are actually directories. You can look inside an iOS application by right-clicking and show package contents. So you can do this on any Mac that you're sitting at and have a look at the contents of an iOS application. As an example of accessing a read-only file, let's add a simple text file to an application and then read the data in that file from the application. So the first step is to create our data file and put it in the source/assets directory for our application. So this is the location where we can add read-only files for our application. The data file will be called data.txt and will contain a simple string of hello world. The file plugin has a number of read as styled functions. So we have a read as text, read as data URL, read as binary string, or read as array buffer. In this example, we'll be using the read as text, which requires a path and then the name of the file to be able to read in that file. So reading the file as text is fairly simple. This is an asynchronous call, so here we're using a promise syntax. So we've got our file.readAsText and we're passing in a directory and then the name of the file. So we've got our, and then the val that's going to be returned is going to contain the entire contents of the text file as a string. The first parameter is application directory, indicating that we want to read from the read-only storage, so files that were built into the application. The second parameter is the path to the text file. Note that it starts with the www and not src source, as when an Ionic app builds, the contents of the source directory are moved into the www directory. So remember to rebuild your application so that the data.txt file that you may have copied into the source assets directory can be moved to the www/assets directory. This is an important thing that you must remember to do a rebuild at this point. So note that we can't write to read-only storage that is in the application directory path. So then the following example that we have here will write a new file into the data directory. So this data directory is our writable location. So we will then call our file.write file, passing in a directory, the name of the file, and the data that's to be written into that file. So note that the third parameter can also be a blob or an array buffer, which we could then use actually to write images. We can read the file from the data directory using the same method as reading from the read-only directory. So using a promise syntax, we can see here that we can read as text, and instead of being from the application directory, we'll be pulling from the data directory. Or we see an alternative syntax there using async await, where we're doing exactly the same thing. If your application stores images in the data directory, it is possible that there could be a name clash. For example, the user may select a photo from the photo gallery with the name of image153.jpg and also a photo from the SD card with the same name, taken from a different camera. Therefore, you must be careful when using the original file names. One solution is to use your own file names with your own counter. So you will need to store the current counter value in storage. So a sample algorithm for making this work is we could initialize our counter to 0 in storage, load our counter from storage, store a file with a name of img and concatenating with our variable of counter and JPEG. We then increment our counter, and then for the next image we save, it will be the next one in the series. So whatever algorithm you use, it is important that you prevent duplications of file names. You may want to create subdirectories for your data to keep things tidy and avoid name clashes. So we can use the create dir function, where we create a path, the name of the directory we'd like, and we can send through an option for whether we would like an existing directory to be replaced or not. So when the app launches, you may want to create the directory but not force it to be replaced. You can check if a file exists before attempting to read or write to it, and this is a good thing to do, using the check file, passing in a path and the name of the file. This will pass back either a true or false to the promise that's returned. You can also check if directories exist using the check dir method. Files and directories can be removed when no longer needed. So we can use the remove file or remove directory methods to do this. Let's have a look at a sample app using the file plugin. So here I've created a default blank application. So in my app directory, I contain a home component. I have already been in and added the Cordova plugin and also done the npm install for the Ionic native version for the file plugin. So let's have a look at the code. So we start off at our app modules TS. So here is where we're going to add in our import of our file module for our native plugin, remembering to add /ngx onto the end of the name. And we also add file to the providers array of the ng module decorator. So we've added it there. The next bit we'll go to is we're actually going to display on the home page. All I've done here is created 4 buttons. One which will read a file that is created at design time. The next button, when we click on it, will write a file into the writable area. We've got another button here which will view a file from the writable area, and we've got another function here to delete the file that we wrote. The file that we're going to have here in our read-only file is located in our assets directory, and it's called data.txt, and all it's going to have in it is the words hello world. The key bits come down into then our home page .ts file. So here we have to then import file again. Remember, it's from ionic-native/file/ngx. Don't forget the ngx. We then inject this module through our constructor. So then we have access to all of its methods within this particular component. Here I've got 4 functions. One, which is when we click on to read the data from the assets directory. Remembering that in our notes, we said that it had to come from the www. In the build process of our app, when we build for Cordova, this www directory will be created, and it will contain all of the files that make up the particular website or your web app. So this is using a promise syntax, and basically we're going to read this data.txt file as text, and we're going to do an alert returning whatever the value of that text was. In the write file, we're going to basically write the file, and we're going to write the words hello world 2 to a file called writedata.txt, and it will be in this data directory. Then I'll put a little alert onto screen just to say that the file had been written. When I want to view a file, first I want to check that the file actually exists. So here I'm using promise syntax. So I'm checking that the file exists. If it does, then I'm going to do the next bit, which is then to actually read from that file. If there was an error that the file did not exist, then I will set out an alert to say my file does not exist. And similarly to that, my delete file, first I check that the file exists before I do the delete. So let's compile this and run it in an Android emulator. So for that, I'm using the Ionic Cordova run, remembering the run does the 3-step process of preparing, compiling, and deploying to a device. And the device that I'm going to is an Android emulator. I do have Android Studio installed. So we'll just do the process. It takes a little bit of time depending on the speed of the machine you're running on. This can take a little bit longer to do, but we'll just sit back and wait for this to happen. Nearly done. I'll just bring up my emulator that I have running here. I had this already running. It just speeds up the process that once you have the emulator up and running, don't shut it down, leave it open, so that subsequent runs of it, you don't have to sit and wait for the Android operating system to boot up fully. So if we look at what we're going to do here, when we click on our read from static file, we'll be running this function here, which should alert out the value that was in this data.txt file. The write file function will write out hello world 2 to this writedata.txt file. The view written file will check that the file exists and then write out what the value of it was, which should be this hello world 2. And the delete written file will then delete this write data file. So let's click on each of these and see what happens. So if I click on the read from static file, we get alert hello world, which is the value of the text that was in the www/assets/data.txt file. If I try to do a view written file, I should come up originally, because I haven't written it yet, that the file does not exist. If I write to the file, we've been told that the file's been written. Now if I try to view that written file, I should get up an alert with the hello world 2. If I delete the written file, file has been deleted, go to view it again, get a message that the file does not exist. Try to delete it again, file does not exist. So that's a simple example of using the file plugin. One extra thing to note is if we check out on here, I'll just close this down, that the name of the app that's created in this one by default is just called My App. If we'd like to change that, we can do that in our config.xml file. So over here, we'll open that up. And we'll get into this in the next video where we look at deploying our app. But in this section here, we can change the package name for our particular application. We can then change the name that our application is going to be, description of our application, and there's all sorts of extra information that we will change. And these are all deployment issues of having the right splash screens and icons, etc. for your application for its particular platform. But we'll look at that in the next video.